Okay, guys, so hopefully we did well on our quiz and you're feeling pretty confident. The notes today are pretty short. It is continuing probability. We call it compound probability. So far, we have only done simple probability, which, if you remember from the quiz you literally just took, referred to experimental and theoretical probability, and also just simple probability where you have like a spinner and you have to figure out what's your chance of spinning a blue. For compound probability, we actually have two new topics. They're called independent events and dependent events. And the reason we call this compound probability is because we want to know when two or more events are going to occur. Most of the time it is going to be two events, but sometimes it could be three or four. These events are typically, I don't want to say unrelated, but they don't go hand in hand necessarily. Like before when I said rolling a 2 or 3 on a dice, you would get 2 out of 6. This is going to then talk about a dice and a coin, for example. So independent events is when we have two events, which I'm just going to call A and B. They are independent if the first event occurs and does not affect the second event. Okay? Dependent, though, is when the first event does affect the outcome of the second event. An example of independent events would be if we are, let's say, like I already said, rolling a dice and flipping a coin. Rolling a dice is not going to change what you get on your coin. They're two completely unrelated events, but we could figure out if we wanted to roll a 6 and we wanted to flip heads, we could figure out the probability of both of those things happening. Whereas dependent events, they do affect each other. So an example for this one would be, let me think here, taking a pair of socks out of your drawer and not putting them back. This is dependent because the first time you had, let's say, 10 pairs of socks. You take one out, now you only have 9 pairs of socks because you're going to go wear those socks and not put them back in the drawer. So it affects that second piece of your problem. So let's go ahead and do example 1 now that I've been rambling. So we're going to draw 2 marbles from a bag, and we're going to say that the bag contains 5 blue, 6 red, and 3 green marbles. So our first question is, what is the probability, that's what that P means, that we're going to choose a red and then another red with replacement. So if we're putting it back, that is going to go ahead and be independent because we are not changing how many objects are in the bag. So first we need to figure out the total amount of marbles we have. And I see 5, 6, and 3. So 5 plus 6 is 11, plus 3 is 14. Okay, so if we want to choose a red marble, what's the probability that we're going to get a red marble? 6, right? 6 out of our total, which is 14. And if we're replacing it, that's very, very important because we're still going to have 14 marbles in the bag. So our denominator is still 14, and our numerator is still then also going to be 6. You still have 6 possibilities of choosing a red marble. And then we multiply straight across. We could use that lovely cross simplifying we learned. Divide by 2, so I have 7 and 3, 7 and 3, so that I end up with 9 over 49. That's the probability that you are going to choose a red 2 times with replacement. 9 out of 49 chances. So now let's talk about this next example. What's the probability that we're going to choose a red and then another red, so it seems the same, but this time it's without replacement, meaning when we pull a red out, we're not putting it back. So this is dependent. So the first chance when I go to draw, I have 14 marbles in the bag and 6 of them are red. Hopefully you notice we're multiplying here. For compound probability, you always multiply. So now the second time, if I'm not putting that one marble back that I just pulled out, I now only have 13 in the bag. And I want to choose a red again. And so if I pulled a red out, you always assume you do what you want to do. So if I pull a red out, I now only have 5 reds left in the bag. So we can look to see if there's anything we could simplify. I do notice that 6 and 14 can reduce, so I'm going to do that now to save me work later. And now we're going to multiply straight across. So I have 3 times 5 is 15, and 7 times 13 is 91. And I don't think that can be simplified. So that is your probability without replacement. Okay, so what I'd like for you to do now is I'd like for you to do the group problems on pages 78 and 79. You can do these with a partner, so if you want to wait till somebody else is done with this part of the video, you can. I ask that you please pause the video, check your answers on Google Classroom, and you really need to be working with a partner that is a productive partner today. So pause the video and come back when you are done with the group problems for a little bit more. All right, welcome back. Now I would like for you to please do the formative on Google Classroom and follow the rest of this to do. So you're going to do the formative, then you're going to update your formative chart on page 61. The percentages are on the left side of the TV. And then if you get done with that before everybody else is ready, you can work on the alone problems or the extra practice problems on pages 80, 81, or 82. So make sure you are working and you are focused. And if we have time, we'll do the task cards around the room in a little bit. All right, have an awesome day and an awesome weekend. I will see you guys on Wednesday.